In this video, we're going to use the tower law to compute the degree of the extension q adjoin root 2 root 3 over q. Now, we've already seen examples of this, so we already kind of know what the answer is, right? So set theoretically, we've shown, if not this extension, or if not this field, a very similar field where you adjoin two roots can be described as the collection of all q linear combinations of the element 1, there's really p times 1 there, I'm not going to write it, plus, well, q linear combinations of 1, root 2, root 3, root 6. In fact, you had a homework problem in homework 4 on showing 1, root 2, root 3, root 6 were linearly independent, and in fact they do in fact span, so it's a basis. So 1, root 2, root 3, root 6 is a q basis for q adjoin root 2 and root 3. Great. So we know, so a priori, we know what the degree is. The degree is, of course, 4. There's 4 elements in the basis. Let's compute this a different way, using the tower law to show you how you might go about it that way for less obvious extensions. Okay, so we can view, so alternatively, with the tower law, we can view adding root 2 and root 3 as a two-step process. Okay, we can first pass from q to adding in root 2 to adding in both root 2 and root 3. We can also add in root 3 first. The end result is, of course, the same. These are equal, these are equal. Or we can actually do something else. We can add in root 6 and then add in root 2 or root 3. It doesn't matter because root 2 times root 6 is 2 root 3. So if I add in root 2, I get root 3 from this. And so these are also equal as well. So we can pick any one of these. All right, I'm just going to go ahead and I'm going to pick the first one because it's first. But you could, if you want to follow along with one of the other examples, you can do that as well. So or either of the other two. Let's say that. And it might even be instructive to go through with one of the other examples here. Okay, so this first guy here in gold is a tower. I first add in root 2, and then I add in root 3 to the new field. Okay, so by the tower law, we know that the degree of the large extension is a product of the degrees of the intermediate extensions here. So I can compute that, and then I can compute this. Okay. Now, the degree of q adjoin root 2 over q, we've computed q adjoin root 2 set theoretically already. This is degree 2. And we'd like to say that when we add in root 3, we get something new. But we don't actually know if we get something new. If we do get something new, then it's 2. But we might not have any new elements. So it's either 2 or 1. Okay. So how do we rule out the or 1? Well, we need to show root 3 is not an element of q adjoin root 2, in which case it will have to be 2. So let's show that. Well, what does it mean that the square root is not there? It means that if I take an element there and I square it, I cannot get 3. I'm never supposed to get 3. So this should lead to a contradiction. Can't seem to write. Let's try that again. Okay, so what happens if we square this out? We'll get p squared plus 2q squared plus 2pq root 2 equals 3. And what this means is, on the right-hand side, we have sort of 3 plus 0 root 2's, right? So we get this system, p squared plus 2q squared is 3, 2pq is 0. This last guy here tells us p is 0 or q is 0. Well, if p is 0, then 2q squared is 3, because this guy is 0. And so this tells us that q squared is 3 times 2 to the negative 1, but you, on your first homework assignment, you were investigating when this was a rational number. And the only way that you get the square root of something like this being a rational number is if the exponents are all even. Okay, so this implies q is equal to plus or minus root 3 times 2 to the negative 1, but that's not a rational number. So we conclude that p cannot be 0. Right? If q is 0, then again, reading the first equation, that one's 0. So we get p squared is 3, which implies p is plus or minus root 3, which is again not a rational number by that homework problem. A very helpful homework problem. Okay, so what we've learned is we can't actually square something in q adjoin root 2 to get 3. So we can conclude that the field q adjoin root 2 does not have a square root of 3. It doesn't have either of them. Okay, so that means it's a new object. And so when we add in root 3 to q adjoin root 2, we get 2. So if we go back to our tower law computation above, go ahead and rewind if you need to. It should be the one we just computed times the previous one. Right? It should be the one we just computed here times the previous one, and that was a 2. So 2 times 2. So we get 4, which is what we should get. And this is just another way to go about that.